with the same way like, but in this slide, I want you to know that the following. If lambda mentioned in the Lagrange multiplier method called the Lagrange multiplier, and it gives approximately the change in the value of the optimal function when the constant b of the constraint changes. Why? When you change this value from, if it was like the previous problem, 100, and increase the 100 by 1, then the value of the objective function will be increased by the value of lambda. So for the previous problem, lambda was 25, and the constraint was limited to 100. If it is 101, then your objective function will increase by 25 times lambda, as you can see, which is really a significant meaning. Okay, that's another problem, exactly similar to what we did exactly. This is the Lagrangian, same way like this is lambdas equal to string, get the gradient vector, both the equations, try to solve them together, substitute in each other. The maximality point is at x is equal to 3 and y is equal to 3. We already solved this previously by the two methods. Get the Hessian, which is gonna give you the value of the function. It is 2 greater than 0, then your function, it's a maximization problem, as you can see. Also, I think I added this problem, and it's required to use a graphical approach, then using Lagrange to identify the same solution. And probably, if I would like to ask you about this in the final exam or in the third midterm, I feel this is really a very satisfying or a very nice method, very nice problem I can give you. Also, I've added this exercise for the Lagrange multipliers. Before we go through it, I want you to see this problem if I have more than one constraint. The only difference will be in the Lagrangian function. This is f, this is lambda 1 times the first constraint, lambda 2 times the second constraint, lambda 3 times the third constraint. The procedures will be the same, and all the steps will be the same, but it will be a bigger problem once you get the gradient vector. Instead of dealing with 3 variables, you will be dealing with 4 variables, 5 variables based on the number of the constraints. Okay, as I told you, those are the main steps that we will use in order to charge if we have more than, as I told you, more than one equality constraint. This problem also is really very nice. It's in the 3 dimension of x, y, and z, and subject to one constraint in the x, y, z. The same steps, just about the Lagrangian. Try to differentiate, but we will differentiate 4 times, as I told you, for lambda, for x, for y, for z. Try to substitute, get the value of lambda, substitute back. This is the critical point with the value of lambda. Try to get your Hessian, but in this case, I will evaluate the last, I will evaluate also the last, the last determinant, which is gonna be by 4, and compare them together in order to get the value, since they are both less than negative values, so we will have a minimization problem. This is also another problem I've added for you, and it is depend on the Lagrangian multiplier, but in this case, I will depend on the point that we used in evaluating the calculus of the graphical solution. So get the gradient vector of f and put it equal to the gradient vector of your condition times lambda. This is also going to follow the same procedure exactly like the Lagrangian. And also, I've given you, I gave you this problem, which is xy equal to x squared plus y squared equal to 1. The same steps, get the gradient vector. Of course, I can solve it using the Lagrangian directly, but here I preferred to get the gradient vector of f, the gradient vector of g, then making the Lagrange system, gradient f equal to lambda, gradient of g. Now I have the system, as I told you, I will substitute from these two values into the condition, and then from this relation, I can find that the value of x is equal to 4 lambda square of x, and then I will study each option. Either x is equal to 0, and if x is equal to 0 and you substitute in here, y is gonna equal to 0. If x is equal to 0 and y is equal to 0 and you substitute in the condition, it will be a contradiction. So this is why when x is equal to 0 and if y is equal to 0, this is going to be a contradiction for the condition. So I will reject it. This is why I've added this problem with you. The second option, it will be 1 minus 4 lambda squared equal to 0, which means lambda is equal to positive or negative half. Take these two values and substitute. You will be able to get the value of x and y. They are both equal to each other. Making the substitution will leave you with x is equal to positive or negative root 2, and that's exactly what we faced previously in the problem of solving xy, and the constraint was a circle. These are the points. The least of them is going to be a minimization, and the highest is going to be a maximization problem. Please try to go through these problems. They are the proposed exercise, and they are really very direct, using either graphical Lagrangian or using the substitution method with the Lagrangian and with the graphical. It will give you enough training in order to use in the future, inshallah. And that's mainly what we have for this week. We will continue next week, inshallah. Thank you very much, and wish you the best of everything. All I want you to do is to try once more to solve as much as possible from these exercises using your hand. Thank you very much, and we will see you next time, inshallah. Thank you.